Welcome, students, to today's lecture on the cardiac cycle.
Let's dive into the fascinating world of heart physiology.
The cardiac cycle, a tale of two phases.
The cardiac cycle consists of two main phases, systole and diastole. During systole, the ventricles contract, pumping blood out of the heart. The right ventricle, despite its thinner wall, pumps the same amount of blood as the left ventricle, ensuring equal blood flow throughout the body. Diastole, on the other hand, is the time of ventricular filling. The mitral and tricuspid valves open, allowing the atria to contract and push blood into the ventricles. This phase has two parts, with the second part featuring an atrial kick that pushes an additional 20% of blood into the ventricles. Pressure changes in the heart. The cardiac cycle involves 4 phases of pressure changes in the ventricles. Isovolumic relaxation phase. Both aortic and mitral valves are closed, and the ventricle relaxes without filling. Ventricular filling phase. The mitral valve opens, allowing blood to flow into the ventricle. Isovolumic contraction phase. Both mitral and aortic valves are closed, and the ventricle contracts. Rapid ventricular ejection phase. The aortic valve opens and blood is pumped out of the heart. Key pressure values. Left ventricle 15 to 120 mm. Right ventricle 5 to 25 mmHg. Right atrium 4 to 5 mmHg. Pulmonary arteries and left atrium 10 to 25 mmHg.
Aorta 8 to 120 mmHg.
Preload and afterload. Preload refers to the volume of blood in the ventricles at the end of diastole, while afterload is the resistance the left ventricle must overcome to circulate blood. Understanding these concepts is crucial for grasping heart function and the Frank-Starling curve, which illustrates the relationship between preload and cardiac output. Now, let's explore these concepts further and examine the Frank-Starling curve in a future lecture.